today I'll present our paper about the evaluation of third-party cookie policies. First, to show you why third-party cookie policies are highly relevant today, I will show you two examples in the context of cross-site attacks, but also online tracking. So first, a few days ago, they found vulnerabilities for the OpenEMR system. This is an open source software solution for managing health records. And one of those vulnerabilities was a CSRF vulnerability that could compromise the data of patients. Also, there has been an online tracking study of about 200,000 users in 2016. And they found that of all visited pages by these users, 95% actually initiated cross-site requests to potential trackers. And of these, 78% attempted to transfer potentially identifying data. So in this paper, we evaluated the implementations of third-party cookie policies of browsers, but also extensions. And we found bugs for most browsers and also for all extensions. So quickly an outline of this presentation. First, I'll tell you why you should keep an eye on your cookies. This is a little background information. And then I'm going to explain how we actually managed to do the comprehensive evaluation for which we developed a framework. Then I'm going to tell you what's actually wrong with your browser's third-party cookie policies. And in the end, I'll give a short conclusion. So why should you keep an eye on your cookies? Let's start with some web fundamentals. One important aspect of the web is the way in which we can include resources from other domains. So for example, when we have a domain A, which hosts an index page, and in this index page we want to include an image hosted on domain B. So we can do so by simply referring to this image by placing a HTML image tag. So when a user wants to visit our index page, the browser will send an initial request. When rendering this page, it will notice a reference to the image, and it will automatically send a separate request to fetch the image. This is called a cross-site request. Now, another important aspect of the web is HTTP cookies. These are small amounts of data that can be used by websites to store information on the user's device, and from then on, these are implicitly included when the user visits the website. Cookies are used widely for means of authentication and identification of users. And they are also subjected to the same origin policy. So for example, when domain A sets cookies, those cookies are only accessible by domain A and will only be included in requests directed at domain A. So when we apply HTTP cookies to the example on the left, we'll see that the first request will include the cookies of domain A and the last request those of domain B. So because this last request is actually a cross-site request, these cookies are called third-party cookies. Unfortunately, the implicit authentication due to cookies can be exploited by cross-site attacks. For example, we have CSRF attacks, cross-site scripting attacks, and cross-site timing attacks. To freshen up your memory, I will give an example of a CSRF attack. So assume you want to visit a website called Cute Kittens. So the browser will send an initial request to fetch the page of interest. But the person behind this website might not be as cute as the content hosted on this website. And he actually wants to attack your account on doggerbank.com. He does so by the code snippet below. He tricks the browser into sending a request to transfer funds to a person called CatBoss. So because the browser thinks it's fetching an image, it will gladly send a request, including authenticating cookies we might have of doggerbank.com. Now, luckily, we have access to third-party cookie policies, which will protect us against these exploits. Also, implicit identification through cookies can be misused, for example, by tracking. This can be the purpose of targeted advertising, social media, but also web analytics. So this example is quite similar. So again, a cross-site request is initiated by a code snippet, and the cookies included to, in this case, parbook.com, might be used to identify us or to link the visit to a browsing profile. So again, we can use third-party cookie policies to protect us against these exploits. So let's see what third-party cookie policies actually exist. First, we have some built-in browser options, like the option to block all third-party cookies. However, this option is quite intrusive because a lot of benign web functionality actually relies on third-party cookies. So an answer to this might be Firefox tracking protection or Opera ad blocker, and these make use of blacklists. So essentially all requests or cross-site requests directed at blacklisted domains will be blocked. Also, there is Safari Intelligent Tracking Prevention, which uses more of a machine learning approach. Also, we can install extensions that act as a third-party cookie policy or a similar policy. And we have two major groups of these extensions. So on one hand, the ad blocking extensions, on the other hand, the privacy protection extensions. And then a recently introduced technique called same-site cookies, which I'll explain in a bit more detail. So you can think of a same-site cookie as a generic cookie with an extra attribute called same-site, and the value of this attribute is assigned by the website that sets the cookie. It can be assigned one of two values. The first one is strict, and in this case, the website essentially tells the browser that this cookie can never be included in any cross-site request. The other value is lax, and it's essentially the same, although there are some exceptions to it. For example, the cookie can be included in cross-site requests that are top-level GET requests and cross-site requests initiated by pre-render functionality. So let's see how we can use such a mechanism to protect ourselves against cross-site attacks. So again, the example of doggobank.com. This time when a user logs in for the first time, doggobank uses same-site cookies to set the authenticating cookies. And we can see in the set cookie header that they used the option of strict. So this time when the attack is performed again, we'll see that only the generic cookies are included in the request, which do not authenticate the request. So in this case, the attack is mitigated. So now that we know which third-party cookie policies exist, it still raises the question, why do we actually want to evaluate them? Well, first reason is browsers, which are known to exhibit inconsistent behavior, also implement some of these policies. And this inconsistent behavior can be due to the interference of web standards, but also due to unintended side effects by code modification. Also, we know that extensions have been actively bypassed in the past. For example, by Pornhub, who bypassed ad blockers by using the WebSocket API. What we propose is a comprehensive evaluation of these policies based on effectiveness. And now I'm going to explain how we managed to do this. So we developed a framework for this, and we went with a black box approach. First reason is we don't have to review any code. And there's actually valid reasons behind this. For example, browsers consist of millions of lines of code, and source code isn't even always available. Also, there's many interesting extensions that we want to test. So in those both cases, we thought that code review would not be that feasible. So this is how we applied the black box approach. We see the browser instance as a black box. It's the combination of a browser, an extension, and a configuration. This is then given to the framework, which will run all tests and eventually output bypass detection data. So this is the design of the framework. I will discuss the two most important parts, which are this one, it's about controlling the browser, and this one about detecting which mechanisms actually can initiate cross-site requests. So we control the browser in two ways. The first and most advanced way is through Selenium. It's a tool for browser automation, although not all instances that we want to test are supported by it. So for these cases, we have to fall back to the command line interface. Also, we include a web server in our framework. And this web server hosts pages that initiate automatically cross-site requests to blacklisted domains. And the proxy in between the browser instance and the web server makes us able to trace back the request to the mechanism that initiated the request. So, like I said, we use some mechanisms to initiate these cross-site requests. Although browsers are complex things, and they have a lot of ways to trigger these cross-site requests, but to the best of our knowledge, we have collected all these mechanisms and divided them into different groups. For example, the group about JavaScript embedded in PDF files. Some browsers allow us to send cross-site requests by opening a PDF in a PDF file. Also, you can be redirected to a cross-site domain, although it's important to notice that most of these policies actually do not see this as a cross-site request, because eventually the user will interact in a first-party context with the previously cross-site domain. So let's see what's actually wrong with your browser's third-party cookie policies. First, an overview. We tested 7 different browsers, of which 4 support same-site cookies, and 31 ad blocking extensions and 15 tracking protection extensions. So this is the data we got from testing the browsers and their built-in options. So on the top axis, we have these 7 different mechanism groups. On the left axis, the browsers and their built-in options. So a full circle in this table means that at least one mechanism in the mechanism group was able to send a cross-site request to a blacklisted domain, including cookies. And a half circle means that this request did not include any cookies. An empty circle means that no request was sent at all. So it's a lot of data, but I will highlight some important findings. The rest you can find in our paper. This one, for example, it shows us that Chrome and Opera are the only browsers that allow you to initiate cross-site requests by JavaScript embedding in a PDF. And what's interesting is that it even bypasses their own built-in option to block third-party cookies. Then for the other options to block third-party cookies, for example, in Safari 10 and Edge 40, and we see that those are not as effective. We found multiple mechanisms that can bypass this option. Then for the more advanced options like Opera Adblocker and Firefox Tracking Protection, we found that those are also not as effective as advertised. Although Safari 11, in which Safari Intelligent Tracking Prevention is enabled by default, is quite effective if we don't count the redirects group, because it managed to block all third-party cookies. Then as for the extensions, we did not find any extension that was able to block all third-party cookies, and we found several reasons for this. The first one is that the extension API that is provided by the browser is actually insufficient in some cases. For example, cross-site requests initiated by PDF files in Chromium browsers are simply not interceptable using the extension API. Also, similarly, in Firefox, the requests used to fetch the favicon are not interceptable in this way. Also, sometimes the extension API is unclear. For example, sometimes it's not easy to distinguish requests made by browser functionality and requests made by websites. So in these cases, extension developers are very reluctant to touch these requests because it might break your browser. Also, we found some common mistakes made by the extension developers. For example, requesting insufficient permissions to intercept certain requests. So to come back to the PDF case in Chromium browsers, the PDF reader in these browsers is called PDFium. And like I said before, you're able to initiate a cross-site request. This can be a GET or POST request. So what we expect should happen is this. The extension API should be able to be used to intercept these requests as an extension, but this is not the case because PDFium is actually seen as a plugin or extension. And by rule in Chrome and Opera, extensions cannot intercept requests from each other, so this is what actually happens. The extension API is completely bypassed, making no extension in Chrome and Opera able to act as a complete third-party cookie policy. And like we already saw in the table, it even bypasses their own built-in option to block third-party cookies. So we also evaluated the same-site cookie policy. And we found in Chrome and Opera that this policy can be bypassed by using the pre-vendor functionality. In this case, the lax and strict same-site cookies are included, while this is only allowed for lax same-site cookies. Also in Edge, we found multiple bypasses for both these same-site cookies. So let's see how we can use such a bypass to make an attack successful again. So again, the case of ToggoBank, they use same-site cookies for authentication purposes, but this time Cute Kittens, or the person behind it, has read our paper and uses pre-vendor functionality to bypass this policy. So in this case, the same-site cookies are just included in the cross-site request, making the request authenticated again. So we also evaluated the framework. We wanted to see if it was complete, if there were already some bypasses being used in the wild that we did not detect, but also if any bypasses that we had detected were already being used in the wild. And for this, we used a distributed crawler setup. We intercepted requests with a headless Chrome instance using the Linux network namespaces. And we analyzed all cross-site requests initiated by the websites that we visited. And this gave us an indication of completeness because we did not find any mechanisms that initiated cross-site requests that we had not detected with our framework. And on the other hand, it also gave an indication of novelty because the detected bypasses of our framework were not detected in the wild used by trackers. For this, we used the Alexa Top 10,000. In total, we visited 160,000 web pages and analyzed all cross-site requests that were initiated on these web pages. So then we've come to the conclusion of this presentation. First, what did we find? We found that built-in browser policies can be bypassed. This holds for the same-site cookie policy, but also for the much older third-party cookie policies. Then as for the more advanced options like Opera Adblocker and Firefox tracking protection, these are also not as effective as we expected. Then we also found that all ad blocking and privacy extensions can be bypassed. This is due to the extension API that's provided by the browsers, but also due to common mistakes made by the extension developers themselves. So as future work, we want to expand our framework to include policies in one direction. So we want to include support for private browsing mode, but also for security policies like content security policy. But we will also want to expand platform-wise. So we want to support mobile browsers, for instance. Our goal is to make this framework a tool for comprehensive and automated evaluation of policy and security analysis of security and privacy policy implementations. And I want to motivate this for a second. So let's go back to the pre-runner bug that we found in Chromium. It bypasses the same-site policy in those browsers. So it was originally reported for Chrome 57. And of course, not all bugs are immediately fixed. So it was still present in following versions until version 61. But then it was fixed starting from 62. But unfortunately, we found it again in Chrome version 66 until the latest version. Now this, according to us, shows the importance of the way to do a comprehensive evaluation, because this way regression bugs can easily be avoided. So this was my presentation. I also want to refer to our website, Who Left Open the Cookie Jar, to show you more information about the framework and also more details about the results that we found. Thank you.
All right, so I have a question actually to start us off. Have you reported any of these issues that you've seen to the browser vendors? And similar to actually the previous speaker, what was their response?
So for all browser issues, we reported them using the bug trackers that they provided. And some bugs are already fixed, but some are still in progress or being assigned or being confirmed, but all this information is available on our website. As for the extensions, we also contacted the extensions in which we found the common mistakes, which can be solved by the extension developers themselves. So we reached out to every developer.
Okay, I see. And also some of the issues that you identified seem to stem sort of from the complexity of these policies. Are there ways in which you would ideally want to see the policies change, or do you have any sort of fundamental lower level thoughts about how you might want to avoid issues like this going forward?
Well, I think policies are heavily intertwined. So when you change the implementation of one policy, it directly affects other policies. So in this way, policies should maybe be more contained such that problems cannot go further than their own boundary.
Sure, so. Absolutely. Well, then let's thank the speaker.
Thanks.